Stanford University.
All right, so welcome to Lecture 7, CS193P, Stanford. Today we are going to discuss a few things, mostly controllers of controllers, but at the beginning I'm going to take a few minutes to cover a little bit of some miscellaneous topics, including IB outlet memory management, initialization code in view controller, and some tips for memory management, how to get memory management right. And then after that, we'll start talking about more controllers of controllers, specifically UI tab bar controller, and then a couple that are iPad only, UI split view controller and UI popover controller. And then I'm going to talk about universal applications, how you build a single application that will run on the iPhone and also on the iPad, because there are some considerations there. The platforms are very similar. They're both iOS platforms, but they're a little bit different in certain ways, screen size being the most notable, that you have to program for. All right, so let's talk with some of these miscellaneous topics. This one is IB outlet memory management. We talked about how to do that last time. You do it with this @sign property retain IB outlet business. There are two subtleties, though, to consider when you do this, and I just want to make sure everyone appreciates the subtleties, and maybe by considering these subtleties, it'll help you understand better why we do it with that @sign property retain thing. Okay? So the two subtleties are, do you want your outlets to be public? Because if you put @sign property retain in your header file, they're public. Somebody could send a message to your calculator view controller's display and set something in there. Not clear that's what you want. And then number two is, do we really want to be calling our outlets setter in dealloc? And I'll talk about why that might not be such a good idea necessarily. All right, so let's talk about the public nature of these things. So here I have a header file above the line and an implementation file below the line. Nothing new here. This is how I told you to do the outlets. You can see that we have an instance variable, UI label outlet, and we have a property, which is retain. And then in our implementation, so in viewDidUnload and in dealloc, we say, we call this helper method that we made up called release outlets that does self.outlet equals nil. Now, in this arrangement, you can see that our outlet called outlet, which is UI label, is public. So anybody could send a message to it to do whatever they wanted. That's not so good. So here's another version of this that addresses both of these subtleties. The first thing you can see is that I've removed the @sign property retain IB outlet UI label star outlet. I've moved it from the header file down into the implementation, into that little magic parentheses business. And by doing that, it's not public. Now, one thing I said last time, I believe, is there's really no such thing as public and private when it comes to sending a message in Objective-C. Everything is pretty much public. But by putting it in its header file, you're advertising it. Then you're really making it public. All right? So by taking it out of the header file, we no longer are really advertising it. From a code point of view anyway, it's private. So you can see that's one change we've made there. Notice that when I did that, I went back and made sure that my instance variable said IB outlet, UI label star outlet, which I didn't have in my first version. And that's because I still want Interface Builder to know about this thing. Now, Interface Builder can still call the setters and getters for my outlet, the setter basically, even though this is now private, because those methods still exist, and Interface Builder uses introspection. Right? Remember we talked about introspection? It uses that to figure out whether there's a setter to call, and then it calls it. So we're still good on the Interface Builder front, but we want to put that little IB outlet magic in there just so that Interface Builder knows about it when we're wiring things up, that's all. And then also you notice I no longer have this helper method release outlets, and instead I still call self.outlet equals nil in viewDidUnload, but in dealloc I call outlet release. Now, why in my dealloc would I not want to call the setter, self.outlet equals nil? Dealloc is kind of like you're off the cliff. If you remember Wile E. Coyote, right? Roadrunner's already run you off the cliff. You're heading for the bottom of the canyon, okay? So you really don't want to be trying to work on your rocket pack and do things. You're about to hit the ground, okay? So calling your setter there might have side effects, even though you're calling your setter with nil. It could have side effects where it's sending messages or doing stuff that is irrelevant, first of all, and second of all, might be doing something that really is going to be invalidated in a few femtoseconds when you hit the ground, okay? Because dealloc, it's too late. Everything is over. In dealloc, really all you want to do is release your memory usage, and then, because you cannot stop yourself from being deallocated here. Okay, so it's a subtlety. You see why it's a subtlety. It's not necessarily wrong, especially if you don't implement your own setter, because the default setter, all it does is, releases the old version and sets the new one, so it doesn't really do much. But it's a little maybe safer. Okay? So that's that. You can chew on that, think about that. It has don't worry about it for your homework and all that stuff. It's not going to change what you do for your homework. These are subtleties. All right, another thing that I wanted to make clear is view controller initialization. How do you get your view controller initialized? Because we talked about the life cycle of view controller last time, remember? And we talked about how it goes through view did load, and view will appear, and then view will disappear, and then all that. But it's maybe not 100% clear, how do we get ourselves initialized? How do we get our instance variables set up? And so let's go through it a little more carefully here. There's really 4 places to initialize things, approximately, in view controller. There's the initializer, the designated initializer, init with nib name bundle. We talked about that. So you could override that and do the self equals super init with nib name bundle and then do some stuff and return self. That's possible. There's this method awake from nib, which you were rudely introduced to last time, and I'm going to talk about what that thing does. And then there's view did load, which you know a lot about. Okay? And then there's view will appear. So the question is, where do I put my initialization amongst these 4 places? All right, we talked a little bit about the differences, but I just want to make sure we're clear. So the designated initializer, usually you're only going to put things in your designated initializer that have to be initialized for your class to even make sense. In other words, if you don't put them in there, then your class is going to be in some nonsensical state. It's just not even going to make sense. And there's very few things that are that way. And in good class design, you try and make it so that your class works. Maybe it doesn't do everything it's supposed to do, but it doesn't fail and be in some wacky state when you don't initialize. But that's really the number one thing that goes in your initializer, things that have to be initialized for your view controller to even make sense. Remember that its view is not even loaded at the beginning. So your view controller better make sense without having its view loaded, right? Because it's not loaded at the beginning. It only gets loaded on demand. All right? The interface builder file only gets loaded in when it's actually going to be used. Some people think of the designated initializer as a place to initialize things about your model, which that's sensible, although good design also might just make your model be a property on your view controller, like we did with psychologist, right? We had the happiness just be a property, the happiness view controllers had happiness be a property. That's a pretty good way to go. So that just means your view controller has to work if your model is nil, okay? But you could put that in your initializer as well. It's definitely not for initializing things in your view, though, because again, your view is not loaded until it's needed. But there are some UI-related things, like the title of your view controller, which might appear in certain places in the UI. We'll see that later today. That you might want to initialize in your designated initializer, possibly. Okay, so now what about awake from nib? Awake from nib, the same things go in awake for nib that go in your designated initializer. Right, so what is awake from nib? Awake from nib is a method that's called on every object that comes out of an interface builder file instead of its initializer. Okay? So your designated initializer for your view controller, for example, not going to get called if your view controller comes out of a nib file. So like when you do view-based app in Xcode and you get that template, your view controller is in main window.zib. So it comes out of a nib file. Your initializer will not be called, but awake from nib will. All right, and vice versa. Like in psychologist, I created that last time in the demo with alloc init. So its initializer got called, but awake from nib never got called, and that's why we had a problem where things wouldn't show up. So these two both are pretty much going to do the same thing. And in fact, I recommend creating a new method called setup or something like that, and have your designated initializer and awake from nib both call it. I do not recommend calling awake from nib from your designated initializer, or certainly not vice versa. Okay, that really is semantically not right. Okay, you have some other method, which is your initializing method, the method that sets your class up. Call it from your designated initializer and from awake from nib. Does that make sense? So that's the role of these two. They're pretty much the same function, but one is when things come out of a nib, and one is when it's alloc and knitted, basically. So then view did load. I'm not really going to talk much about that. I think we covered that. View did load could be called multiple times because your view could be loaded and then unloaded for memory recovery purposes and then loaded back up again. So you wouldn't want to put things in there that really belong in the designated initializer or awake from nib that are only going to happen once. Again, the reality is view did load is probably not going to be called multiple times, but this is called after your zip file has been loaded though. So if you have any initialization to do with your view, here's the place to generally put it, is view did load. But you also have the option of view will appear. And why would I put something in view will appear instead of view did load? Two reasons. One, because the initialization I'm going to do depends on the geometry of my view. In other words, my view has to be on screen with the size it's going to be before I can initialize something. I got to wait till view will appear because my bounds is not going to be set properly in view did load. It just came out of the zip file. It's going to have some default bounds, might get moved around by the navigation controller or a tab bar controller or something, might squish it around. So we want to wait till view will appear. Second reason to wait till view will appear besides geometry is performance. All right, because I might have my views loaded, but they don't actually appear on screen yet. I don't want to do something really expensive until I'm sure I have to. I'm going to wait till I'm just about to appear, then I'll go do something expensive. So that's the other reason. We talked about that last time too. So I'm just going to reiterate that. All right, so that's view controller initialization. I especially wanted to make sure you get the initializer and wake from nib and understand what their role is there. All right, another little miscellany here is about memory management. So you've all been doing memory management, and I told you before we don't expect you to get it all right. We expect you to kind of get better with each assignment. And so people have asked me, though, can I have some rules or something to think about when I'm doing memory management to try and make it easier to remember what I'm supposed to do and all that. So I tried to come up with some. I'm not sure this helps a lot, but it might help a little. The first thing is when you type alloc or copy or new or any method that starts with those, an alarm should go off in your head. So you want to train yourself, whoop, I just allocated something, I own this, where am I going to release it? And I would right then go put that release somewhere. Okay, before you forget, before that thing just, you know, it's an hour later, someone distracts you, you forgot about it, right then go put a release somewhere. Now, if you just alloced an instance variable, probably that release wants to go in your dalloc, right? Because that's generally where we release instance variables. If it's a local variable, probably that release wants to go later on in that method, either right before you return or somewhere. So just put it in there somewhere. Even if you haven't written the rest of the method, just put it there so you remember that, I got to release this thing before this method returns. If it's a local variable that you're returning, it's the return value, then you got to auto-release it, right? We know about that because we're giving it away. We need to release it, but we have to delay our release of it until the person we're returning to has a chance to retain it if they want. So that's the number one way to not have memory leaks, is have this alarm go off in your head when you type one of those methods. Watch out for the case where you set a variable multiple times in your code. Like you might have an instance variable and it has a certain value and then someone sets it to a new value. Okay, when they set it to the new value, if it's an object that got alloced or something like that, or you retained, you got to release the old value before you retain the new value or do the new alloc, okay? The best way to fix this mistake or to make this not happen is to use @property retain. Because if you have a property for that instance variable and you use this dot notation to set it, the retain, when you synthesize, when you do the @synthesize for the property, it'll automatically release the old version and retain the new version. Okay? So that's a great thing about @property retain. So I strongly recommend if you have an instance variable in your object that gets set multiple times, either internally or by some external public property, that you just do @property retain. You'll still have to do release of that thing in your dalloc. Okay, so don't forget about that. But in the middle, when you're setting it to different values, at least you'll be releasing and retaining the new one, releasing and retaining the new one. Okay? Go immutable. right? The things are all immutable. These NS arrays and NS strings and NS dictionary, they're immutable for a reason because it helps with memory management. Okay, immutable objects are much less error prone. You're much less likely to be in a situation where you alloced it and then you didn't release it or something like that. So go immutable, and I'm going to show you a slide, an example of that. And then the last one is try to use other methods other than alloc and do and copy. Okay, go use methods that return auto-released objects, because then you won't have to worry about putting release anywhere, right? So try to use those, and I'm going to show you an example of that as well. But there is something of caution there. When you do that, if you're using a lot of auto-released objects, you don't want to do them in inner loops. You don't want to, remember the picture of the pool that I did last time where you go around the loop and all those auto-released objects end up in this big pool and they all get released at the end? You don't want to have that pool having thousands of objects in it. Use that pool for, dozens of objects, maybe 100. You want it to be fairly small. So if you have an inner loop that's generating thousands of objects, you do not want to use auto-release in that inner loop, and I'm going to show you an example of that as well. So here's a couple examples. All right, so here's a way I have, this might be the method that returns the test variables for my calculator, right? It's called test variable values. It returns an NS dictionary. And the way I create it is I'd say NS mutable dictionary, return value equals NS mutable dictionary alloc init. The alarm just went off. I got to release this thing. Okay, it's a local variable. I'm going to return it. So I'm going to put return value auto release at the end. I'm going to put that in right away before I forget. And then in the middle, okay, I'm going to set the objects that I want to return in my mutable array. Okay, this is probably what you did. You might have done something like this in your code. So that's fine. It's not bad. Okay, it's fine. Here's better. Instead of doing the alloc init and the auto release at the end, use this method NS mutable dictionary dictionary. That returns an auto-released NS mutable dictionary. Now I don't have to do return value auto-release. So I saved myself having an alloc in my code, which always sends off alarms. Oh my gosh, I have an alloc, blah, blah, blah. This way I don't have an alloc. Okay? And I return that value. Everything is totally kosher here. So this is cleaner code. But there's even better. Okay? The best is to use immutable. So here's the exact same thing. And you can see here, I'm asking NS dictionary to do this class method dictionary with objects and keys, and I'm passing it the objects and keys I want in there, nil terminated there, and this is going to return an immutable NS dictionary with the stuff in it. And now look at this. A, it's a lot less code, one line of code. B, there's no mutable going on. I don't have to worry about things being changed or whatever. It's all nice and immutable. And memory management is fine here because dictionary with objects and keys doesn't start with alloc, new, or copy, so it returns an auto-release thing. That's what I want to return. This makes sense, these three different versions? All right, so here's another example. This is the thing about don't let that auto-release pool get huge. Here's bad. So here I have a method called 10,000 Gs. All right, it returns a string with 10,000 Gs in it. Okay, and it does this using our friend string by appending string. So you can see I start with an empty string, and then 10,000 times I do s equals s, string by appending string, g. Right? So sure enough, I'm going to end up with a string at the end that had 10,000 Gs, but I'm also going to end up with 9,999 auto-release strings along the way, because every time I call string by appending string, it gives me back an auto-release string. So that pool is going to be just, literally we'll be underwater with these auto-release strings, okay? That's not good. We do not want to do this. So this is bad. Do not do this. All right? So what is a good way to do this? Well, mutable. This is where we'd want to use a mutable string. So here I create a mutable string. Now I'm using this method sappend string. That's not creating anything or anything. It's just sending a message to that mutable string saying add this onto yourself. The mutable string does it itself internally. And then I'm saying return auto-release because I still have to return an auto-release string. Okay? So that's good. No problem. But there's even better, similar to the best in the previous slide, which is instead of calling NS mutable string alloc init, I'm going to call NS mutable string string, which is a method in NS string that returns an auto-release string. And if I send it to NS mutable string, it returns an auto-released NS mutable string. Now I append the G on there, and I return S. I don't have to do that return S auto-release. Okay? Same exact thing we did last slide at the end. All right? So that's my help for you on memory management. Stay away from alloc, new, and copy unless you actually have to have it. Make sure you get that alarm bell and put your releases in there. Question?
For that bad example, what if you put S release before you did the new string?
Yeah, so the question is, well, okay, the question is, in the for loop and the bad example, when I'm doing S equals S string by appending string, could I put a release in there on the inside of the loop? Is that what you're talking about?
Yeah, I call 2 releases.
Yeah, then you'd get 2 releases, one auto released and one not. You could ask another question, could I alloc init a new one that appended it and then release it? But you wouldn't want to do that either. You're better off using the mutable, which has its own internal management of the fact that it's building this 10,000 G thing. So, okay, so that's it for the 3 kind of miscellaneous things I wanted to cover. So now we're going to go back to today's primary topic, which is controllers of controllers. And the first one I'm going to talk about is UI tab bar controller. If you've used the iPhone, you know exactly what this is. Here's some examples on the screen. The tab bar controller is the thing that puts the 4 buttons along the bottom there of each of these 4 different modes in the clock application in this case. And as you click on each button, it loads that view controller's view. Those views are not loaded out of the zip file until you click on the button. So this is why I'm saying you might have a view controller. It exists, but it's not loaded yet. Right? The view hasn't been loaded because no one's clicked on that tab. And we don't want to waste the memory of loading all 4 tabs worth of buttons and picker views and things like that if the user never going to click on that tab maybe. Okay? So this is a tab bar controller. So how does a tab bar controller work? It basically has an array of view controllers. You can have as many as you want. It's not limited to 4, and I'll talk about that in a moment. So it's an array of view controllers. And here's how you build one. So here's a typical application did finish launching with options. And I'm going to build a view controller, or tab bar controller that has 2 tabs in this example. So first couple lines there, I'm just getting my view controller somehow. I'm alloc initting them, or somehow I get them. Then I'm saying UI tab bar controller equals UI tab bar controller alloc init. This is just like when I did UI navigation controller alloc init. I'm basically, here's where I'm creating and initializing my controller of controllers, my tab bar controller in this case. Then tab bar controller has a very important property called view controllers, which I'm setting on the next line. The view controllers property takes an array of other view controllers. And that's how you specify to the tab bar controller, here's all the view controllers that I want you to have tabs for. All right? And you can set that property later. If you want to add more tabs, take tabs away, you can always change that array. Everything's fine with memory management there because NSArray returns an auto-release thing, and I'm sure tab bar controller is going to retain that thing, but I'm not going to retain it because I'm not going to use it. Notice on the next line, I'm releasing my 2 view controllers, my VC1 and VC2. Because once I've put them in the array that goes off to the tab bar controller, the array is going to retain them. And if the tab bar controller wants to use them, it's going to retain them too, maybe, unless it keeps that array. So I don't need them anymore, so I'm just going to release them. In fact, I have to release them here if I alloc them. All right, does everyone see why I'm doing that VC1 release, VC2 release? And then I'm just adding the tab bar controller's view. It's a view controller. The tab bar controller is a view controller, just like navigation controller. So I'm adding its .view property to the view hierarchy, and then make key invisible. Question? So the question is, do the icons at the bottom show up automatically when you push the view controller? And that's what I'm going to talk about next. Thank you. So what does appear on those little tabs? Where does that information come from? Well, by default, you get no icon, but you'll get the little word, like timer there, from the UI view controller's title property. So all UI view controllers have this property. It's an NS string called title. Now, you haven't been setting that, although we did set it right at the end of the psychologist demo. We were setting the title there. You set the title of your view. In a navigation controller, it'll show the title at the top bar. In a tab bar controller, your view controller's title will appear on the button. Okay? Or if you want to get that image in there, you can set another property on UI view controller called tab bar item. So tab bar item is a property whose type is a pointer to an object, UI tab bar item. And you can go look at what a UI tab bar item can do. But here's an example of creating a UI tab bar item. So this method, notice, is not it's not init or awake from, or sorry, it's not view did load. It's this method setup that I might call from my awake from nib or from my init with nib name bundle. That's because I can't call it in view did load because I want my tab bar item to appear before my view is loaded, because it might be one of the other tabs that they haven't clicked on yet. So my view is not loaded, but I still want its icon and its title to appear. So anyway, so here's the UI tab bar item. I'm creating it. There's two ways to create it. This example is init with title and image. You specify the image you want. It'll scale it. It'll even do the nice little, see how it's gray when it's not selected and it turns kind of blue? It'll do that magic for you as well. There are some guidelines, the best way to create icons so they look the best. That's in the documentation. But that's how you create a tab bar item with its title and image. That tag, don't worry about the tag. It's just an identifying tag. You can ignore it. Just press 0 if you don't want to use it. But obviously there's API to look things up by tag later if you wanted. And then I just say self, assuming this is in my UI view controller, self.tabBarItem equals that item. And then item release. Once I hand it off to tab bar item property, it's going to get retained, and I don't need to keep a pointer to it anymore. But I alleced it right here, alleced and initted it, so I better make sure I release it. Okay? So there's another version of this called init with system item, and there's about a dozen different kind of system item icons there, like a search item and bookmark item, I think, things like that. So you can peruse those, see if some of those icons might work for you. And if you do it that way, the system item will have the icon and the text that goes with it. So the search system icon would have like a searching, like a magnifying glass or something icon, and then the text is going to say search, although it would get overridden by your title. Okay, your UI view controller's title would override that. And then once again, tab bar item equals item, item release. Okay. So that's how we set those tabs. There's also another thing that can appear on those tabs, which is a little badge. So you might be used to this. This happens on application icons as well, like your mail icon can have a little badge, how many unread messages you have. This looks very similar to that kind of badge. The way you set that is this property called badge value, which is a string, and it's a property of the UI tab bar item. So if this code is in UI view controller, my UI view controller, maybe it's a target action thing or something else happened to cause me to want to show that badge, then I would just say self.tabBarItem, which gets me the UI tab bar item that I set on the previous slide, .badge value equals R. And that's going to call the setter for that, and that's going to cause this red thing to appear. This one with the letter R on it, you could put a little number in there. Obviously, if you start getting really long strings, it's going to start looking pretty bad. You know, my experience is that you can get up to like 3-digit numbers, perfectly fine in there. They'll be kind of oval shaped. Words up to 3 or 4 letters maybe might fit there, but mostly it's for numbers. Usually we use it for numbers, like the number of unread mail messages, things like that. All right, so what happens though if there are more than 4 view controllers? Because I said the tab bar controller, you can create it with an array of as many view controllers as you want. When you do that, a more button will appear down in the corner. So you'll have 4 buttons and a 5th one now, which is more. And when you click that more, it goes into this mode where the user can actually pick which 4 they want to be showing on the bar. And at any time, they can click on that more button and pick a different one, right? So they can actually edit what's on the bar if you enable that. Or if you don't allow them to pick what's on the bar, they can go to this more place and choose one of the ones that's not the 4 defaults. All right? And this magically happens. It happens automatically. You don't need to do anything to make it happen. You just add as many view controllers as you want, and it'll automatically put this UI up there for you. So it's kind of nice. Question?
Does it save?
Yeah, the question is, if you allow this to be edited, you know, if you allow the user to edit which of the 4 buttons that are at the bottom, does it save it? And the answer is yes, it does. Okay, combine. Can you combine UI tab bar controller and UI navigation controller, right? Can you put them in the same user interface at the same time? And the answer is certainly. That's quite common, actually, to put them together. The only thing about that, though, is the UI navigation controller goes inside the UI tab bar controller, not the other way around. So this is the code for it. I'm not going to go through this line by line, but the key part of it is that you can see down here, I'm creating the tab bar controller normal way, but the array of objects that I'm setting as the view controllers for the tab bar controller are navigation controllers. See nav1 and nav2 that I created above? So that's how you do it. When you set the property on UI tab bar controller, which is the view controllers you want, those can be UI navigation controllers. But you wouldn't want to go the other way around. You wouldn't want to push a tab bar controller. Okay? All right, so this is what it looks like when you combine them. You can see I got the tab bar on the bottom. It does the right thing in terms of putting the title on the top. And you can see this one has a back button right there. So it does the right thing is the bottom line when you nest them in this way. All right, very common. You see this all the time. All right, so another controller of controllers. So that's tab bar controller. UI navigation controller is a controller of a controller. Here's a third one, UI split view controller. All right. This only makes sense on large screens. You would never use a split view controller on an iPhone. There's just not enough room to do what this thing does, and you'll see when I show it to you in a second. Essentially, a split view is side-by-side views if you're in landscape orientation. So you got an iPad, it's in landscape. The two views are side-by-side. They have a kind of a, they don't have to, but generally they have a master-detail relationship where the left one is the master and the right one is showing some detail that's selected in the master. When you switch to portrait, it doesn't show them side by side anymore. It just shows the right-hand one in the whole screen, and the left-hand one is accessible via a little pop-up button in the upper left corner. It'll make more sense when you see it, if you haven't seen it already. The API for creating a split view controller, virtually identical to a tab bar. The only restriction is when I pass that array, see my split view controller dot view controllers equals ns array with objects, just like the tab bar controller. I can only have two view controllers here though. Whereas tab bar controller, I can have as many as I want, and it manages it all magically. 2 and 2 only for split view controller. If you put more, I don't know what happens, something bad. So don't do it. Okay, 2 only. And it makes sense because it's side by side, only 2 side by side. All right, so here's what it looks like in portrait mode. So you can see this would be your calculator homework next week. So you can see the graph in the middle there, and then my calculator is in a little pop-up that comes down from a button in the upper right corner. And then if I rotate my device, now my calculator is side by side. It's not in that pop-up anymore. Make sense? So it goes from here to here as I rotate back and forth. Got it? Pretty simple. So notice that I have nice little titles above my two view controllers here. The one on the left has a title that says calculator. The one on the right is blank. It shouldn't be. Probably I should have my expression or something, although I don't have any expression graph, so maybe my expression is nil or empty. So, but having those title bars in the top, that does not come for free. That's not something you get with split view control. You have to put those title bars up there yourself. And you really need a title bar there because when we switch back to the other mode, we're going to actually put a button up there in that title bar that brings down the popover. So how do we get those title bars up there? There are classes in iOS that you could use to do it yourself, but the easiest way is to put both your split view views inside of Navigation Controller. Because Navigation Controller knows how to put that title up there, and it knows how to put bar buttons up there. All right? So even if you're not going to navigate, still put them in a Navigation Controller. You get a lot of nice window dressing on those views. So here's some code. Again, I'm not going to go through this line by line. I put it in the slide so you can go back and look at it later because you might want to be doing this at some point in your homeworks, not this week's, but maybe next week. And you can see that I'm just creating two nav controllers, putting my left and my right views in there, and then down here where I say split view controller SVC dot view controllers, I'm putting the left, right, and right nav in there. Okay, so that's how I've got my two things. They have title bars because they're inside nav controllers. What about that button? Okay, so when I go into portrait mode and I have a button up there that brings down this popover, who puts that button there? And who makes the popover appear when the button gets clicked on? So let's talk about that. The answer to the question is you are responsible for putting that button there. That doesn't happen automatically. However, the split view is going to help you enormously to put that button there. You're going to set yourself as its delegate, and it's going to send you this nice delegate method, split view controller will hide view controller with bar button item for popover controller. And this, in your implementation of this delegate method, is where you're going to put that button up there. Now, notice in this thing that you get a bar button item. You see the third argument with bar button item? That's passing you the bar button item that you can put up in that thing. So you don't have to create that bar button item, you don't have to release it or anything. All you got to do is take it when you get this delegate method and put it somewhere. And if you put both of your sides of your split view in a navigation controller, you can do it with one line of code, because navigation controller knows how to take a bar button item and put it on its bar. So I'm going to show you that in a second. I'm a big believer that any view controller that you might have appearing in a right-hand side of a split view, you know, the detail side, you should implement these split view methods. And it's possible to implement them in a way where you have no idea what the left-hand side is. You have no idea what master put you up there. But you can still do all the magic with the button, you know, the popover button and all that stuff. And I'm going to show you that on the next page. Okay, this code I'm going to show you on the next page, you'd put it in a right-hand view controller. It would be the delegate of the split view it's in. And it would have no idea what's in the left-hand view controller. This is what it looks like. So here's the delegate method, split view controller will hide view controller with bar button item for popover controller. The very first thing I'm going to do, I'm going to take that bar button item that it gave me, and I'm going to set its title to be the title of the left-hand view controller. Now, I said I don't know anything about the left-hand view controller. That's true, but I do have a pointer to it because it comes as the second argument to this method. So you can see I've used the two arguments to just take the title of my left-hand view controller, whatever bit, it might be calculator, for example, and I'm putting it as the title of the little bar button, which makes sense, right? Because when I rotate the thing and now I have a little bar button, it'd be nice if the title of that bar button is essentially the title of the left-hand view that got taken away when I rotated. Then the other second line of code is I'm just going to say self.navigationItem.right bar button equals the bar button item I was passed. So this is worth a little time, take a little time out here to talk about this property navigation item. Okay, navigation item is a property on UI view controller. It's an object called the UI navigation item. I encourage you to go look at it in the doc. It has a lot of methods on it that essentially allow you to set things about how a navigation controller is going to look when this UI view controller is on top of the stack of cards. Right? Remember, the UI view controller manages a stack of cards, and when a view controller comes on top, you want the surroundings of the navigation controller to adapt to that thing. Put the buttons with the right title, etc. And this is how you do that. You get this self.navigation item, it gives you back an object, and you send messages to that object to customize how you want the navigation controller to look when your UI controller is on top. Well, remember that in our split view controller, we put both sides in a navigation controller. All right? And so we want to add a bar button, this bar button it's giving to us, as our little popover in the upper left corner of the right-hand view's navigation controller, because it's the only one going to be left on screen when we switch to portrait mode. And that's how the user is going to be able to press that button and get the left-hand view to pop up. Okay? So you can see 2 lines of code and you're done. And even the first line of code is kind of optional. You could set that button title to be something else, like pop up or something like that, but this is probably the best thing you'd want to do. There's 2 other delegate methods here that you get. One is that this happens when it rotates back. So the first one you got when it rotated to portrait mode, you get this delegate method when it rotates back. And all that happens here is you don't need that button anymore, because now that left-hand view is back on screen as the left-hand side. So now you want to take that button away, and we do that by saying self.navigation item right bar button equals nil. And that takes that button away. Okay? And then this third one, this one you get when the left-hand view controller is going to be presented on screen. But in our generic version, we don't do anything here, because this is generic. We're trying to be a generic right-hand view, like our graph view controller. you know, it doesn't want to know anything about the calculator. Remember I told you that your expression graphing view controller doesn't want to know anything about the calculator view controller. And this is true here too, even in a split view. So we're not going to do anything. Now, if we had an incestuous relationship between our two controllers, we could do something here if we wanted to. I recommend against it, just to keep your MVC clean. No back pointers. Okay, new thing, popover controller. So that button, so that's it for split view controller. That's all you need to do, and it'll just work. Very little code to make split view work. UI popover controller, yes, it's the same thing that's used to bring that popover up. But we're not talking about using it in context of a split view controller anymore. In fact, we're specifically talking about using a popover controller now outside the context of a split view controller. Because inside a split view controller context, we're going to do what we did on the last few slides. But now, for some reason, we want to have a popover appear, and it's not in a split view. So when do we want to do that? Before we get into that, let me make it clear. This is not UI popover view controller. It's UI popover controller. It is not a UI view controller. It is different than tab bar controller, split view controller, and navigation controller. Those all are UI view controllers. UI popover controller is not. Okay, it is not. So I'm going to show you how you use it, given that it is not a UI view controller class. You put a UI view controller in it, but it itself is not one. The way it works is it pops up on screen from active areas. Now, what's an active area? Well, one active area is a button on a toolbar. That's how the split view makes a popover come up. But another active area might be a text selection. So, for example, in the iBook app or in the Kindle app, when you select some text, you can click on it, and it'll bring up a little popover that lets you choose cut, copy, paste, but also dictionary definition. And if you click up dictionary, it'll bring another popover up, and it'll point to the little selected piece of text with the dictionary definition inside the popover, okay, which is kind of cool. So the popover pops up on screen, and it points. It has an arrow, which we'll see in a second. It points at some active area, presumably the area that caused it to appear on screen. Sometimes, for example, if you're thinking, I want to do split view, but I actually want the right-hand view to be on the screen all the time in both orientations. And I always want to have that popover button bring up the popover, right? And I'll show you an example of that. In that case, you would not use UI split view controller. You would have to implement it yourself and use a UI popover controller directly. So here's an example of an app that does that. See, here it is in portrait mode. It's got the right-hand button. But when it switches to landscape, look what happened. The thing didn't go to the left. Right? The thing inside the popover does not slide over to the left like in a split view controller. It's still appearing as a popover. So if you wanted this kind of UI, then you would have to implement this yourself with the popover controller. All right? So let's talk about the implementation of that. How do you do a popover controller? First of all, you see the little triangle at the top there? That's the popover's arrow. In the API I'm going to talk about, when I talk about the popover's arrow, that's what I'm talking about. And whenever we put a popover up, we're going to have to control a little bit of where the popover can appear on screen, because we might not want it to cover something else up. And the way we do that is by restricting where that arrow can point, up, down, left, or right. So this particular popover is popping up with its arrow direction being UI popover arrow direction up, right? The arrow points up. Now, it might be moved a little bit to the side or whatever, but the arrow is going to be pointing up, right? And there are other arrow directions. We're going to look at that. So how do we create a UI popover controller? With alloc init, but it's not alloc init end, it's alloc init with content view controller. All right, so this is its designated initializer. And you can't call alloc init. It won't work because this UI popover controller, the argument there, the view controller, cannot be nil. You cannot create a UI popover controller with no UI view controller inside it. It has to have a UI view controller inside it. Okay? So that's why its designated initializer requires you to provide a view controller. Okay? It is possible, however, though, to change the view controller that's inside of a popover controller by setting this property content view controller later. But you can't set it to nil. It'll ignore trying to set it to nil. So the popover always wants to have a view controller's view inside of it. So the way this works, you create the popover controller with the view controller that you want to appear inside of it, like your calculator view controller, for example. And then you send this message, present popover from rect in view, permitted arrow directions, animated. Okay, this is one of the two methods you can send, actually. So the rect, a rect there, is like the rectangle that the selected text is in. Okay, that would be the rect that it's appearing from. In view would be like the text view that the selected text is in. It's the view that has the active rectangle. So that rect is going to be in that view's coordinate system. Okay? And then permitted arrow directions, this is how you control where the popover can appear. If you only allow it to have, arrow direction up, then the popover is going to appear down below that selected rect. But if you allow it to be up or right, then it might appear the arrow up or right, then it might be below, but it also might appear to the left and have the arrow pointing right. Okay, so you can control the direction. Or you can pass arrow, UI popover arrow direction any, and then it might appear anywhere on screen. Then you don't mind, yeah. If there's not enough room is the question. So you have popover, you say put it up there, and there's just not enough room. Well, it's going to smash it on there. It's going to jam it onto the edge. And so that's your responsibility as a UI designer to make sure that condition can never arise. The user can never put it in a position where the poppers are going to come up and not fit in where you intend. So that's your responsibility. But the answer is it's going to put it up anyway. All right. There's another way to put it up. If you're putting it up from a bar button, right, it's not coming up from selected text or something. It's a bar button like in the split view controller case. There's a new one here, or a different one here, present popover from bar button item. And you just specify the bar button item and permitted arrow directions and whether it comes up animated, right, whether it slides in or fades in or whatever, and then it will do it. The animation that it uses to come in, again, it's kind of like navigation controller. You always want that to be yes if this view controller is on screen, and that's almost always true in a popover case because the thing that pops it over is usually something that's already on screen. So it's very unlikely that you would have animated no here. All right. So this popover comes up, and we've controlled where it can appear somewhat. Okay, somewhat constrained where it can appear. How about what size it is? How does it know what size to be? And there's two ways. One, you can set it by sending a message to the popover controller, set popover content size, give it a CG size, and it'll set it. If it's already on screen, it will animated resize to the new size. Okay, it's kind of nice. Or you can implement a method in your view controller that says, if I'm in a popover, this is what size I should be. Okay? That's the way to do it, because that's object-oriented. Right? That view controller has the best idea on the planet how big a popover, how big a rectangular space is necessary to contain its views. Right? So that's what I recommend is in your view controller, implement content size for view in popover. So we got the popover on screen. It's the right size. How do we get rid of it? How do we dismiss it? Well, the number one way that popovers are dismissed is that the user touches outside of the popover. Okay, touches on some other view, touches, on a bar somewhere, touching outside. That's the number one way. It is possible to do it with code with this dismiss popover animated method. You would do that if maybe the thing it's pointing to got invalidated, and so it doesn't make sense for the popover to be on screen anymore. It'd be pretty rare, usually the user clicking over it. There's a bunch of API in popover, in the delegate, etc. Well, we'll get to that in a second. First of all, how do we tell if the popover is on screen? It's got a property called is popover visible, and that'll tell you whether popover is on screen. This is what I was saying. The popover has a delegate to prevent and get notified of dismissal. So sometimes the user might touch somewhere and you don't want it to go away. You want that popover to stay up until the user does something in that popover. Okay? That's kind of probably not so great a UI. Users expect after a while that if they touch somewhere outside the popover, it's going to go away. But you can do it. And then also you'll get notified with this did dismiss popover when that does happen. But these methods are only sent when the user initiates the action. If you call dismiss popover animated, you won't get these two neither of these delegate methods will get sent your way. All right? There's also a bunch of other mechanism in there for saying if the user touches on this view, don't dismiss it. If it touches on this other view, do dismiss. That's outside the scope of this class. Edge cases anyway, don't worry too much about that. But if you see that when you go look this up in the API, that's what that's about. All right, so that's it for controllers or controllers. All right, so we talked about the four main controllers or controllers. The popover controller is not really a UI view controller of other controllers, but all four of those things basically have other view controllers inside of them, and they let you build more sophisticated user interfaces. So the last thing we're going to talk about today, universal applications. So here we're attempting to build a single application that will run on the iPad and on the iPhone. Okay, a single binary image that the user goes to the App Store, they buy it, they download it on their iPad, it runs. They go over to the iPhone, they click to buy it again. The App Store says, you've already purchased this. Do you want to download it again? You say yes. Now you download it to your iPhone. Now it runs on your iPhone. So it's the same binary. Okay, comes down to both platforms, runs on both. Now at first, you might think this is, well, let me back up here. First you might think this is easy. It's all just iOS. I'll just build my app and off I go. But you can already see from earlier in today's lecture that's not true. Because on an iPad, you might want to use a split view. On an iPhone, you might want to use a navigation controller. So how are you going to manage that? Also, the iPad does not run iOS 4. It's running iOS 3.2. So if you use some method or functionality that's in iOS 4 and you try to run this thing on an iPad, not going to work. It's just not going to be there. There's not going to be any implementation for it. So we're going to talk about how to manage all that. So the first practical matter is if you want to build a application that runs on both, I recommend the following steps. Take an application that you created for the iPhone, okay, an iOS 4 application you created for the iPhone, and go into your and we'll do this on Thursday, don't worry. As usual, I'm going to demo everything I talked about today on Thursday, except for tab bar controller. We'll do that next week. So you're going to go into Xcode, and you're going to find your application. It's just like all your class files, your application file is also in Xcode in the groups and files area, right, where the little folder is classes and the folder resources. Well, if you go down farther, there's one called targets, and inside there's your application. And if you right-click on your application and choose Get Info from the menu, you'll kind of get all your application settings. The settings are used to build your application. Along the top, there are 4 tabs in that window. One of them is Build. So you can click on Build. And then in Build, you're going to scroll down until you find the property, the build property called iOS Deployment Target. All right, it'll be set by default to be probably iOS 4.1 or whatever you're currently building in. But you can change it to be iOS 3.2. When you change this property, iOS Deployment Target, to property on your application, right, to build property for your application, when you change that property, it means you are willing to have this application run on iOS 3.2, if that's what you set it to, or later. So setting your deployment target to 3.2 doesn't mean it's only going to run on 3.2. It means it'll run on 3.2 or later. It's like the minimum iOS that is on the target device that you're running on that you're willing to accept. And if you tried to run this on an iOS 3.0, it would just not run. It'd probably put up an error panel saying this application does not support iOS 3.0. All right. So now you have told Xcode that you want to build a target that will run on 3.2 or later. But you still have a lot of work to do here, depending on your application, to make the application universal. For example, if you call 4.0 API, like I was saying, you probably need to use introspection. Right? So here's a really good example that you want to pay close attention to for your homework next week, which is, what if I call this method content scale factor, which you're hopefully calling this week in your homework. Content scale factor is the thing that tells you how many pixels per point there are on the screen. Well, that was added in iOS 4 because in iOS 4 we have the Retina display appearing, this really ultra high resolution display on the iPhone. But in 3.2, there were no devices where a point didn't equal a pixel, so this method doesn't even exist. So in your draw rect, you would want to call the introspection method we talked about earlier in the class called response to selector, and you want to ask and this is in your draw rect, so you're asking the view class by saying self. If self responds to content scale factor, then I'm going to call it and use the result. Otherwise, I'm just going to use 1.0, which is the old value. In other words, you use introspection to see if a method's there, and if not, you got to make a decision. What am I going to do? That feature's not there. In this case, it's really easy. You're just going to use a content scale factor of 1 pixel equals 1 point. So you're off and running. But you might have other methods that you're going to call that are iOS 4 only, and you got to think of what you're going to do when you go run on a platform that doesn't have it. All right? And so that's one thing you can use, introspection, to decide. You also might make your code conditional on what kind of controller you're in. Right? You got a view controller, it's running, it knows whether it's in a split view or in a navigation controller, and it might do something slightly different on those two contexts. So it's not really checking to see if it's on an iPad or checking to see if it's on an iPhone. It's just saying, if I'm in a split view, then I'm going to do something. If I'm in a navigation controller, I'm going to do something just a little bit different. Like if I'm in the navigation controller, maybe I'm going to push my next view. Whereas if I'm in a split view, maybe I'm setting it to be the right-hand side. I'm using the split view API. You see how we can do that depending on what our environment is? So that's one thing. And remember that all UI view controllers know what kind of controller they're in. They have these methods, self.splitViewController, which I use an example here, the self.navigation controller. So you can self.popup controller. I don't know if that really, it's a split view controller, navigation controller anyway. It knows what it's in. You can use that to kind of make your decision. All right, so that's another way. How about one, whether you're on screen or not? Okay, so if I'm writing the code for the right-hand side of a split view controller, if I'm on the iPad, somebody's already put me on screen. I'm sitting there on screen on the right-hand side of a view controller. If I'm on iPhone, I need to get pushed onto the screen. So let's think about your calculator example. You got your graph view, right? Your graph view, when you hit the graph button in your calculator view controller, it pushes the graph view on screen, right? That's not going to be true when you go to the iPad. You're going to have your calculator on the left, and you're going to have your graph view on the right. The graph view is going to be on the screen all the time. So when your calculator view gets to the point where it gets that graph button, like someone hits the graph button on your calculator view, it's going to say, if I don't already have a graph view that's on screen, then I'm going to create one and push it on screen. Otherwise, it's already on screen. I don't need to do anything. I'm just going to send the graph view a message saying, here's your model. Go do what you do. That make sense? You understand what I'm saying there? So how do you tell if a view is on screen? Okay, you're a view controller. You want to know if your view is actually on screen. A simple way to do is ask your view what window it's in. And if it's nil, then you're not on screen. Okay, so saying if self.view.window, then do something means if my view is already on screen, then do something. You could also say if not self.view.window, that would be do this if my thing's not on screen, my view's not on screen. All right, any questions about that? So that's another way to make it conditional. Another conditionality, maybe, pretty rare, how big is my current screen? If I'm on a big screen with a lot of pixels, maybe I do something a little different than if I'm on a small screen, right? So here, you would probably want to find out what your screen size is in points, not pixels, because actually an iPhone has more pixels on screen than an iPad does, an iPhone 4, right? So you want to use this method, UI screen, main screen, bounds. I have too many square brackets there. It'll return the size of your, a rectangle of your screen's bounds in points. And so you probably wouldn't want to check if it's exactly a certain number, but you might want to say if I have more than 1 million pixels, then I'll do this. If it's more than 2 million, I might do that. Make a decision based on that. So kind of rare, but I just wanted to bring an example here of always think about what are you really conditionally making your decision on. Don't just immediately go to the am I on an iPad card, because there might be new devices in the future from Apple. So if all of the above conditionals that I just mentioned don't work and you can't think of anything else that really makes any sense, it is possible to ask the question, am I on an iPad? Okay? And the way you do that is with this macro, UI user interface idiom equals UI user interface idiom pad. And if that is true, if that's equal to that, then you're on the iPad. And there's another one, UI user interface idiom phone. That'll tell you whether you're on a phone device. Like I say, this is not a first resort. This is kind of a last resort. But you do need to pull out this card, fairly often. And so let's look at some code then that tries one more thing, sorry. Conditionally loading a zib, very important too. You lay out your user interface in Interface Builder, right? And on an iPhone, you're going to lay it out as a little rectangle that's taller than it is wide, and you make your buttons a certain width. Well, if you went onto an iPad, you might want to lay out your UI in a completely different way. Put a whole bunch more buttons on there, have a bigger custom view and something, whatever. And you can do that and still have both of them in Interface Builder. And the way you would do that is using the init with nib name, which is the designated initializer of UI view controller, and just pass it a different nib name. And the convention is kind of to do -iPad for the iPad ones. So here I have two zip files. I created them separately in Interface Builder. One's called mynib.zib, and the other one's mynib-ipad.zib. And depending on whether it's iPad or not, I'm picking the right string, and then I'm using that to call init with nib name. Now, there is a way in Interface Builder to take an existing nib file and basically turn it into an iPad one. So just check out the menus in Interface Builder, and you can take something you already have, make it into iPad so it'll be big, right? 1024 by 768, and you can then edit it around from there. It's a little bit of a challenge if you have two zip files. If you're in active development, because you might add something to one, you got to make sure you add it to the other. You got to make sure outlets and actions stay in sync. So it's a bit of a challenge, but it is an option for certain user interfaces to do this. Normally, you're not really going to do this, and you'll see how that works out as the course goes by. Why it's really doesn't come down to this that much. All right. So probably the biggest difference between that you're going to have in your code between the two platforms is in application did finish launching with options. Because on an iPad, you're going to build your main view is probably going to be a split view, right, or something like that. Whereas on the iPhone, your main view might be a navigation controller, or some other difference between the two. But that first main construction that you do in application did finish launching with options, which you're working on now with this week's homework, you're using a UI navigation controller there, is probably going to be different. So let's look at what an application that's trying to support both, what its application did finish launching with options might look like. So I have two view controllers here. I'm calling one master and one detail. So one is a master like your calculator view controller, and one is a detail like the graph view controller, meaning that the master is telling the detail what to do. Now, you don't have this next line of code in your current code, because when it comes time to push your graph view, you just create one. Create it, push it, and release it. Off it goes. Does what it does. But here, you're not. Here, you're creating the detail one in application did finish launching with options. And then I'm going to set a property on my master saying, here, I already created that graph view thing for you. Here it is. Now, why am I doing that? Because on the two platforms, I'm going to do different things with this master and detail. So here, I'm creating a navigation controller for the master. That's all I'm doing here, just creating a navigation controller for the master. And now here's where I'm going iPad or not. So on iPad, I'm going to create a navigation controller for the detail. So now I have both my master and detail in a navigation controller. On iPad, I only have the detail in a navigation controller. And then I'm going to create a split view. I'm going to set its view controllers to be the master on the left and the detail on the right. Notice I'm also setting the split view's delegate to be the right-hand view, because the right-hand view is the one that when I rotate is going to stay on screen but put the little button up there. So it's the one that needs to be the split view's delegate to do that, all that button business we did on a previous slide. And then I'm releasing the master and detail nav because I'm not going to send any messages to them anymore, and the split view already owns them, so I'm good to go. So that's what I'm going to do on the iPad. Then if it's not iPad, then I'm just going to take the master navigation controller and put it as the root view controller. I'm missing a return yes at the end here, but whatever. So you can see that I have this root VC instance variable. and I either set it to be the split view controller or I set it to be the navigation controller of the master, the left-hand side view, and then I'd use that to do the add subview at the end. So on the iPad, I've ended up with a split view with the left and right, both in navigation controllers. And on the iPhone, I've left just the master sitting in a navigation controller. And when you click the graph button in that, or whatever that causes the detail to come up, it's going to push. So this is only part of the solution here. I also need to have code in my master where it has to decide when it's time to push. Am I pushing, or is that thing already on screen? Make sense? Because it'll already be on screen on the iPad case, because I just put it on screen with the split view thing. So this is a common mechanism here. In your application to finish launching, you're going to build some navigation controllers and view controllers, and then you're going to decide how to arrange them on screen using this if iPad or some other conditional, but usually if iPad. Now, you might say, oh, what is that if iPad? That's some instance variable. Maybe I say self.ipad or something like that. I have to call that idiom thing. User interface idiom equals, right? There's no, I didn't want to imply that there is a variable called iPad somewhere. You'd have to set that yourself. Okay, any questions about that? All right, so you've built your application. You've set the deployment target. You've put all those conditionals in there so it'll run on both platforms and use the right user interface idiom depending on which one it is. How do I test it on both platforms? Okay, I want to run it on the simulator, iPhone simulator, but then I also want to test it on my iPad simulator. And yes, Xcode 4 SDK does have a simulator for both. It has a 3.2 iPad simulator and it has a 4.0 iPhone simulator. All right? And the way you switch between those two is a pop-up in the upper left-hand corner of Xcode. You've probably seen it there already. You haven't really had occasion to use it so far unless you've done device development, because that's the same place you go and choose, I want to run it on a device now. And you simply go up there, and if you've set your deployment target properly to 3.2, you'll have a choice. There'll just be two of the choices there. One will be iPhone Simulator 4.0, and the other one will be iPad Simulator 3.2. And you just switch back and forth. It's smart about knowing if you're building that you're always still building with the 4.1 SDK, but you're just targeting when you hit run, build and run or whatever, you're targeting the right simulator. Okay? That's it. You can kind of switch back and forth and try it on one, try it on the other, etc. So that's it. So next time, what are we going to talk about? I'm going to talk about gesture recognizers, have some slides about that. So this is panning, pinching, things like tapping, things like that. And then we're going to have a big old demo. And what I'm going to do is I'm going to take Psychologist and we're going to turn it into a universal application. It's going to use a split view controller. And I'm even going to show you how to handle device auto rotation. We talked about that in slides last time, right? What happens if the device rotates? You want to do something different? We're going to show you how to do that on Thursday as well. I hope I have time for that, but I think I will. And that is pretty much it. So thank you for coming, and I will see you on next lecture.
For more, please visit us at stanford.edu.